you serious? How am I supposed to get out of this part? Oh, no worries. Omnidirectional mode on. Haha, look at that. See you later, guys. Hi everybody and welcome to this week's Lego Technic video. So about 3 or 4 weeks ago now I presented this particular model here. It's based on the idea of a Roomba vacuum cleaning robot, and that particular robot can drive forwards, backwards and rotate on the spot as needed to get out of tight situations. And yeah, I thought it'd be fun to kind of create a model that emulates that kind of behavior by having 4 wheels at the bottom, and those 4 wheels can rotate from either driving in the forward configuration or being in a configuration we can rotate on the spot. Now, I did have quite a few issues with this particular model. It didn't quite work as expected. There was quite a bit of gear backlash, creating rotational issues with the wheels. However, I have been working on a new and improved version. This is Omnidirectional Vehicle version number 2, and I'll be presenting to you today how this one solves a lot of the problems that the previous model had. Okay, so like I said, the idea of this vehicle is going to drive forwards and backwards and rotate on the spot. And in order to be able to rotate on the spot, what you have to do is rotate the wheels in a certain configuration such that you get that rotational movement when you're driving the wheels forwards or backwards. And I'll just show you on a diagram how that would work. So on this diagram here, I've represented the 4 wheels on the left here pointing forward. So the arrows represent the direction of rotation of the wheels. In order to change to the rotational configuration, what we have to do is rotate the wheels by 45 degrees in certain directions in order to create this configuration here. And if we compare the left diagram with the right diagram, you can see that the top left wheel is being rotated 45 degrees in a clockwise direction. The bottom left is 45 in the other direction, so that's anti-clockwise. And then on the right side of the vehicle, we have to rotate each of these wheels by 135 degrees instead of 45 in order to get the direction of the motion of the wheels going in the correct direction. So it has to rotate from pointing forwards to pointing all the way 135 degrees in this direction. And same with the bottom right wheel, it has to rotate 135 degrees in the anti-clockwise direction. And as you can see, that the rotation of the left 2 wheels are in opposite directions. So this one's rotating clockwise and this bottom left one is anti-clockwise. And same with the right 2 wheels, one is rotating clockwise and the other one anti-clockwise, and it's rotating in fact by 3 times the angle, so 45 times 3 is 135 degrees. Okay, so the first problem I had to solve was the rotation of these 2 left wheels, one 45 degrees in the clockwise direction and one in the anti-clockwise direction. Now of course a very obvious solution is to simply have 2 gears meshing like this, and we can rotate them, and we can just rotate them around like that and go from the forward alignment direction to the 45 degree rotation direction, just like that configuration there. Now the problem with this particular solution was that kind of annoyed me was the fact that when you do rotate them in the forward direction like this, there's actually a very slight offset between the gears because of the gear meshing requires that there's a half a tooth offset between the 2 gears. And what that means is when this particular wheel is pointing exactly forwards, the other one is slightly offset. So in the case of 24 tooth gears, that offset is about 7.5 degrees, and so that's something I was trying to solve, and I was trying to think of a way of rotating 2 gears in opposite directions and still be able to have that alignment in the forward direction of both of the gears. And the solution I came up with at that time was this particular gear rack solution. And so what I've done here is I've placed a gear rack in between the gears, and what that allows me to do is to rotate them like I said at that 45 degree angle and still maintain the exact alignment between the wheels when they're in the forward direction. Now of course this solution is very bulky, it's not very elegant. I mean, it does work, but it's not the best one. It's actually quite funny because one of the viewers pointed out there's actually a much better solution, so thanks for pointing that out. And the solution was actually simply just to have 2 bevel gears like this and have another bevel gear in between and rotate them like this, and you'll find again that you can align the angles exactly. They'll be exactly aligned. and you can rotate both of them like this. And of course the great thing about this particular solution is that it allows you to think about this bevel gear as two separate bevel gears, and you can actually separate them because of course the wheels are much further apart than what I've got in this particular example. This is of course very close, and I want the gears to be much further apart. So it's actually a great solution is to then split that central bevel gear into two and change it to this kind of configuration, and that is exactly what I needed for my model. I needed to have both of these aligned, and also by having this axle in between, I can rotate both of them without having lots of gears in between, which also eliminates a lot of the gear backlash that I found in my first model. Okay, so this great solution allowed me to go from this design that I had in my initial implementation of the omnidirectional vehicle. So I used to have that gear rack implementation to be able to rotate the wheels as needed, and of course I had to have a 3-to-1 gearing between the left side and the right side to be able to generate from 45 to 135, so that's around the back. And the problem with this particular solution was there was a lot of gear backlash between the wheels, simply because the distances that had to be covered, as well as the fact that I was driving it just from one of the wheels, and by the time the gears went to the final wheel there's quite a lot of wobble between the wheels. So my new solution was much more elegant, looks like this, using that spread out bevel gear solution. And what the great thing about this is it allows me to drive it from the center, and I can drive it around like this and change the wheel angles into that rotational configuration that was needed, and rotate back into the straight direction. And the great thing about this particular solution, of course, is that the gear backlash has been practically eliminated. There's far fewer gears, and also it's being driven from the center, which means that the distance to each of the wheel rotations is very similar. Okay, so here's the new and improved omnidirectional vehicle version 2. I've implemented those changes that I just explained before in terms of those wheel rotation gearing systems. I have got my battery box up here. I've got the remote receiver. The main wheels are driven by a large power functions motor, and in my previous model I tried to use a servo motor for the wheel rotation, well, that made sense at the time, but that just wasn't powerful enough, so I've replaced that servo motor with a medium power functions motor to be able to drive those wheel rotations. Just demonstrate how that rotation works. So at the moment we're in the forward direction, and I can use the remote and change from the forward direction to the rotational direction like this. So now we can see we're in the rotational configuration, and by rotating back I can go back to the forward direction. Now by having that lower gearing, it makes it reasonably powerful in terms of rotation, so rather than getting stuck I can now pretty much rotate on the spot like that, and go into rotation mode and go back and change back to the forward direction and drive backwards, forwards as well as backwards. Alright, so that's the new and improved omnidirectional vehicle version number 2. Hope you enjoyed this video, got something out of it. Please like and subscribe, and we'll see you next time. Thanks for watching.